Good afternoon, this is Kavi Priya, Assistant Professor, EC Department. I am going to discuss about the topic amplitude modulation. So first, what is this amplitude modulation? In case of amplitude modulation, we will be varying the amplitude of carrier signal in accordance with the amplitude of the input signal, which is nothing but it is a baseband signal. So baseband signal is one which contains the information, where carrier signal is one which is a high frequency signal but it does not contain any information in it. So the first way what we have seen in the previous diagram is a modulating signal, and next one is a carrier, and third one is a modulated wave. Modulated wave is one which is a combination of input signal and the carrier signal. And next is what is this modulation index? A carrier wave after being modulated, if a modulated level is calculated, then such a attempt we call it as a modulation index or modulation depth. So it states that level of modulation that a carrier wave undergoes. So AM by AC is a modulation index. AM is a amplitude of the modulating signal and AC is a amplitude of the carrier signal. So it is often represented in percentage. We call it as a percentage modulation. And what is this under modulation? For a perfect modulation, the value of modulation index should be 1, which means that modulation depth should be 100%. For instance, if a value is less than 1, for example, if the modulation index is 0.5, then the modulated output would look like a diagram that is shown, look like a figure what I have represented in this diagram. So we call this as a under modulation, and the wave we call it as a under modulated wave. And what is this over modulation? If a modulation index is greater than 1, for example, if it is 1.5 or 1.5 more than 1.5, then the wave we call it as a over modulated wave. If it is greater than 1, then we call it as a over modulated wave. The diagram indicates the over modulated wave. So as the value of modulation index increases, the carrier experiences a 180-degree phase reversal, which causes the additional sidebands. Hence the wave will get distorted. Such over modulated wave causes interference, which cannot be eliminated. And what is this sideband? In process of amplitude modulation or phase modulation, the modulated wave consists of a carrier wave and will be having two sidebands. So the modulated signal has the information in the whole band except at the carrier frequency. So sideband is a band of frequencies containing power, which are low and higher frequencies of carrier frequency. So both the sidebands contain the same information. So the representation of modulating wave in the frequency domain is represented in the picture. We will be having the lower sideband, we will be having an upper sideband. Next we are going to see about the double sideband full carrier. So the diagram as shown in the diagram, both the sidebands in the right of the image contains the same information. The transmission of such a signal which contains a carrier along with the two sidebands, we call it as a double sideband full carrier system, or we call it as a DSB-FC. However, the transmission using this is inefficient. So the 2/3 of the power is being wasted in carrier, which carries no information. If a carrier is suppressed and power is disturbed to the two sidebands, such a process we call it as a double sideband suppressed carrier. It is as like the diagram shown. And next one is a single sideband suppressed carrier. The process of suppressing one of the sideband along with the carrier and transmitting a single sideband, we call it as a single sideband suppressed carrier, or we call it as a SSB-SC or SSB. So what are all the advantages of the single sideband suppressed carrier? Bandwidth or spectrum space occupied is lesser than the AM or double sideband. Transmission of more number of signals is allowed. Power is saved. High power signal can be transmitted. Less amount of noise is present. Signal fading is less likely to occur. Drawback is that generation and detection of SSB signal is complex process. So the quality of signal get affected unless the SSB transmitter and receiver has an excellent frequency stability. And application of the single sideband modulation is that for power saving requirements and low bandwidth requirements, we go for the sideband modulation. And in air, in land, and in maritime mobile communication, the single sideband suppressed carrier is used. In point-to-point communication, it is used. In radio communication, in TV, telemetry, and radar communication, we go for the sideband modulation. In military communication, such as armature radio, we go for the sideband communication. So that's all about the double sideband suppressed carrier and single sideband suppressed carrier, and what are all the advantages of single sideband, drawbacks of single sideband, and applications of the single sideband. Thank you.